Assalamu alaikum. Hope you are doing fine. A device which is used to produce high electrostatic potential is known as electrostatic generator. Graaff Generator is an example of one such electrostatic generator. In this video, we are going to learn about Graaff Generator. Let's get into that. Graaff Generator was designed in the year 1929 by Robert Van Graaff. So the device is named after him as Van Graaff Generator. It works on the principle of electrostatic induction, and action at points, otherwise known as corona discharge. Before getting into the topic, let me explain you what these two things are. Let me tell you what is the electrostatic induction. In short form, I read it as ESI, electrostatic induction. Electrostatic induction is a phenomenon of charging an object without touching it. How it is possible to charge an object without touching it? Let me show you. Suppose I have an object which is placed on an insulating stand of this kind. It's placed on insulating stand. This is a hollow metal sphere, I say. Now, beside this, I bring a charged object. Suppose I have a glass rod which carry negative charge. When I do so, see, if you look at this carefully, you will find that there is no contact between these two objects. Still, what will happen? This object will get positively charged. What is the reason? The reason is this have both positive and negative charge in an equal number. So the positive charges present in this object will get attracted towards this. And the negative charges are repelled. So they move to this end. Now, if I ground this, all these negative charges will move to the ground. So only positive charges are left here. Now when I remove this object, then the positive charges gets distributed uniformly on this sphere. This is how one can charge an object without touching it. We call this phenomena as electrostatic induction. I hope you have understood. Now, let's come to the point. What is the action at points? Now, when I remove this charged object, this sphere, in this sphere, the charges get accumulated in this manner. No, they get distributed uniformly. Clear? So, suppose if I take an object which appears something like this. So what happened here? If I provide a charge to this, suppose I provide a positive charge. Now those positive charge will gets accumulated in this manner. As a see, you may find at this end where the radius of curvature is more. The punches are these charges are far apart. Whereas here, where the radius of curvature is very less, the number of charges are more. They are crowded. Correctly speaking, near the sharp edge, the number of charges are more. So here charge density is high. Here the charge density is low. So due to this, what happened? The air in its surrounding gets ionized. No, the molecules become positively and they acquire positive and negative charge. Positive and negative charge. These positive charges gets repelled, whereas negative charges, the negative ions get attracted by this object. So as a result, when these negative ions, negative charges combined with positive charges present in this object near the sharp edge, the number of charges in the object reduces. It is called as leakage, and the phenomenon is referred as action at points. So currently speaking, a sharp charged object leaks out the charge. We call this phenomenon as action at points or corona discharge. I hope you have understood what is the electrostatic induction and action at points. Based on these two, Van de Graaff generator work. So now I will get into the construction of Van de Graaff generator. Let me show you how it appears. A Van de Graaff generator consists of a hollow metal sphere. Hollow metal sphere. There is a hollow metal sphere of a Van de Graaff generator. This hollow metal sphere is mounted on an insulating pillar. So this is the insulating pillar on which this hollow metal sphere is mounted. So it appears something like this. This is here. This is hollow metal sphere. Hollow means which is empty from inside. It is represented by letter E. Okay, and this one is nothing but insulating pillar. Alright? Then, if you look at inside, you will find there is a pulley. B is placed at the center of this hollow metal sphere, and you will find one more pulley exactly below this pulley B, placed within this insulating pillar. See? It is named as C. The pulley B and this pulley B, pulley C. Now, over these two pulleys, A belt made of some insulating material like silk or rubber passes over, something like this. I repeat, a belt made of insulating material like a silk or rubber passes through these two pulleys B and C. Here, pulley C is attached to a motor. It is driven by a motor, okay, in a anti-clockwise direction. Okay. Then, very important thing, beside the belt near the pulley C, there is a Coulomb. Coulomb D is present. This Coulomb has got sharp edges made of metal. It is attached to a high tension battery. Here tension represents voltage, high voltage battery. Now, it is connected to the positive terminal of a high tension battery, whose negative end is grounded. Is grounded in this manner. Okay. So the Metalcone D is at a positive potential. Okay. And here the voltage supplied by this high tension battery is of the order of 10 power 4 volt. Remember this, very high voltage is supplied to this Metalcone D. Now there is one more Metalcone is present within this hollow metal sphere. I name this Metalcone as E. This Metalcone E. It is attached to the inner surface of this Metalcone. It is attached to the inner surface of this hollow metal sphere. This is the construction of the Van de Graaff generator. I repeat this quickly. Van de Graaff generator consists of a hollow metal sphere represented by letter A, mounted on insulating pillars. Then at the center there is a pulley B is present, and below that there is one more pulley C, which is driven with the help of an electric motor. Over these two pulleys, a belt made of some insulating material runs, and beside the belt you will find Metalcone D connected to the positive terminal of high tension battery, which provides voltage of the range of 10 power 4 volt, and Metalcone E is connected to the inner surface of hollow metal sphere. This is the construction of a Van de Graaff generator. Now I go ahead. Now let me tell you how it functions. Well, I told you earlier, Metalcone D is connected to positive terminal. So it is at a positive potential. It is at positive potential, has got a positive charge. Now due to high voltage, the air in the surrounding gets ionized due to corona discharge. This phenomenon occurs here. It gets the surrounding air becomes ionized. Now repeatedly I am using the term ionization. What does it mean? Let me tell you. Suppose I have an object A. This object is completely neutral. When I say it is completely neutral, that means this consists of equal number of positive and negative charge. Suppose it has got one positive charge and one negative charge. So it is in balanced condition, it is a neutral object. Now suppose by some method I remove one charge from this. Suppose I remove electron. Why electron? Electron carry negative charge. So when I remove electron, only positive charge left here. So suppose I remove electron from here. So what is left? This one will have only positive charge. Now this neutral object A has turned into positively charged object. Earlier it was neutral, now it is positively charged object. We call such positively charged object as positive ion. Positive ion. Okay, in simple words, I write it here in the form of an equation. From when A to A, right? Then I removed the electron. So what happened? It becomes positively charged. Positive ion. If you do the reverse thing, what happens? Suppose the same object, I have an object, a positive charge and a negative charge. Suppose I give an electron to this. Give an electron. Okay, and then I subtracted the electron here. Okay, to make you understand this in a better way, I write minus E. Then I have added an electron to this. So the object will have one positive charge and two negative charge. So here the quantity of negative charge has increased. So this object become negative ion. This object become negative ion. Negatively charged. We call such negatively charged object as negative ion. So this phenomenon of converting a neutral object into an ion is known as ionization. So here what we have done? We have separated electron to this. So it becomes negative ion. So due to high potential, what happened? The surrounding air gets ionized. They carry positive and negative ions. Here, positive charge gets repelled by this Coulomb because it have positive charge. We know same charges repel. If you bring positive charge near positive charge, they repel. So the positive charge present in the air gets repelled, and they hit this insulating belt, and it gets stick to it. So these positive charges so got stuck to the belt, moves upward. The positive charges, they stuck and they move upward in this manner. Slowly, the positive charges move along with the belt like this. When they approach this region near the Coulomb E, what happened? Due to electrostatic induction, this Coulomb, this part becomes negatively charged, and another end, this end becomes positively charged due to electrostatic induction. This is how positive charges are accumulated in the metal sphere, hollow metal sphere. So they get accumulated outside in this manner. Then when the belt moves downward, Due to the presence of negative charges in the Metalcone E, the positive charges gets combined. As a result, it gets the belt gets neutralized. So when it moves downward, it carries no charge. Almost no charges present on the belt when it comes downward. Again, when the belt comes near to this end, that region of the belt starts getting positive charge, and the phenomena repeats. So they move here, positive charges are supplied to the hollow metal sphere, and the number of charges increases there. As the charges increases in the Metalcone, we know charge supplied to a conductor is directly proportional to voltage or potential. When the charge increases, potential of the conductor also increases. So here, the accumulation of more and more charge on the metal sphere increases its potential. Okay. Now here, increase in the potential stops at one point, at one limit, called as limiting point or limiting voltage. Usually it is around 10 power 7 volt. So with the help of Graaff generator, we can get a voltage of the order of 10 power 7 volt. Okay, here when we keep providing charge to the hollow metal sphere, the voltage is increasing. At one point, what happens? It starts leaking out charges in the form of sparks. So we need to stop that phenomena. So to stop that, to reduce the leakage of charges from the metal sphere, what is done? The entire setup is kept inside a steel chamber filled with some gas, maintained at high pressure. So what to do? What is done? The entire setup is enclosed in a steel chamber. This is nothing but steel chamber. The steel chamber. Inside the steel chamber, what is present? Gas. Gas is present at the high pressure. High pressure. Why the gas is taken at high pressure? Remember this. At low pressure, a gas becomes a conductor. We know gas is a poor conductor of electricity. It do not conduct a current. But at low pressure, it starts conducting. And the second thing, when the potential is very large, even in such case, due to ionization, the gas starts conducting. This is what happened here. Okay. When we increase the pressure of gas present in the surrounding, then such leakage can be reduced. This is what done here. Now, a question comes to our mind. What is done with such a large electric potential here? Such a high voltage is used to accelerate positive ions such as protons and neutrons, used for nuclear disintegration. Here disintegration means is the opposite of integration. Integration means to combine. Disintegration means to separate. When such a high voltage is given to a particle, the particle starts moving with large velocity. When such high speed particles collide with a target, nuclear disintegration occurs. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.